So basically this question, tangent A equals to blah, 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 cosine B equals blah, okay. I'm going to show you how I do it. Okay, see, tangent A is equals to minus 5 over 12. Okay, and you have, see, tangent negative. Let me talk about the fourth quadrant. And I'm not going to talk about the full story about the fourth quadrant. This one is all, this one is S, sine, this one is tangent, and this is cosine. We call it all school teachers are crazy, okay? Not all Singapore, because if Singapore, I'm inside also, so I don't want to be crazy. So all school teachers are crazy, but not including me. So what this means is all is positive on the first quadrant, sine is positive in the second quadrant, sine is positive in the second quadrant, and cosine and tangent is negative. So this one means tangent is positive, this one means cosine is positive. So let's take a look. This is how I do. Tangent negative, it means that I always put quadrant here. So tangent negative will be in the second and the fourth quadrant. So that means my angle A, okay, can be in the second, can be in the fourth quadrant. This is the first criteria they tell me first. I know they have this one, but that one I will come back to it. Then after that, cosine B, I will write it here. So cosine B is equals to negative 1 over square root 3. Same thing, I'm going to do this. Cosine negative will be in the second and third quadrant. Okay, so it means that my angle A is in the second and fourth. My angle B is either in the second or third. But then they give me one more condition by telling me that, oh, angle A and angle B are in the same quadrant. So we know that we are talking about second quadrant. Then in this situation, I can cross out the second one. And it means that my angle A confirm is in the second quadrant and my angle B is in the second quadrant. Okay, with that, I will always draw out the triangle. Okay, for my way of doing it, I don't like to draw my triangle inside here. Okay, I don't like to draw it there. Okay, I only draw out the quadrant to tell me which quadrant it is that I should focus. Then I will draw the triangle out here. It doesn't matter which direction you draw, as long as it's a right angle triangle. And then one of it, I'll just put it as basic angle. I'll never put A. Okay, because A, technically speaking, you see, in this case is the second quadrant, your A is an obtuse angle. So in this triangle, this is a basic angle, it's less than 90. So I don't like to write A here. I always write basic angle here. Okay, based on this is my opposite because it's tangent, So this is opposite, it means that this is 5. And then after that, adjacent will be 12. So student asked me, do I need to put a minus inside this triangle? In this triangle, when you draw, never put a negative. Okay, the negative is already determined by in this quadrant. So in this triangle, I only need the dimension. So put 5 and 12, and then by Pythagoras theorem, 5 square plus 12 square, you do your square root, you know this one is 13. So you have all the 3 sides now. So now come back to here, they ask for sine A. Okay, very easy. That means I will use, since it's A, I will use the A triangle, which is this one. And because it's sine, which is so, O over H. So with 5 over 13. 5 over 13. Then the next thing is, look at this quadrant. Sine in the second quadrant, is it positive or negative? It is positive. So I don't need to put a minus here. And this is my answer for part A. Now let's take a look at part B. Part B asks for cosine A. So again, it is A. So look at the same triangle and car is A over H. So OA, so 12 over 13. So you write 12 over 13 first. This is the trigo ratio. Next, ask yourself, do I need to put a negative? Because in second quadrant, cosine is negative. So we put minus here. And this is my answer. So this is for A and B. So let's now come to B. Cosine B. Okay, so first, I need to draw my triangle. So I'll draw my triangle. Okay, so over here, I just put my... No, you don't have to find the angle because they're only asking for the trigo ratio. Okay, they ask for the trigo ratio means they only want the so-called the fraction. You don't need to find the angle. Okay, so then after that, cosine B, so basic angle is here. Yeah. So I put here. Okay, technically speaking, this basic angle is different from this one. So if you want to be like very specific, then I use another symbol. I use beta. Okay, then this time around cosine. So that means it's A over H. That means this is 1 and this is square root 3, A over H. Again, don't put a negative. I only want the dimension. So to find the third side, use Pythagoras theorem. So we know that I label this as X. x squared plus 1 squared, then you square root. Wait, sorry, x squared plus 1 squared is equals to square root 3 squared. So it becomes x squared plus 1 equals to 3. So x squared is equals to 2. So x is equals to square root 2. Agree? So of course, you ignore the minus square root 2. That's length don't have minus. So it means that this third side will be square root 2. Okay, this one will be square root 2. Then after that, I put into the diagram. I already have all my 3 dimensions, right? Now you're ready to find your sine B. So as for B, you look at the triangle for the B one. So sine B means it's O over H. So that means it will be square root 2 over square root 3. Because they ask for answer, right? And you must know that you cannot have your denominator to have surds. So you need to do one more additional step, which is to rationalize it. So I have to multiply by square root 3 over square root 3. You must know that rationalizing means you're multiplying by 1. So you're not changing the value. You're just bringing up the surds to the numerator. So you have square root 6 over 3. And this is for part C. Okay, now part D. Tangent B. So very easy already. Tangent B. Now look at the triangle OA. So square root 2 over 1. Okay. Oh, just now I missed one step. Just now I have to check whether this one is positive or negative, right? But because I'm in the second quadrant, sign is positive. So I don't have to put any minus. Understand? Okay. Now part D. Tangent B is square root 2 over 1. So I just put square root 2. Now my question is, do I have to put minus over here? Just type in the chat box and tell me, do I have to put minus square root 2 or is it positive square root 2? Good. Okay. Because you're in the second quadrant, and second quadrant, well done, Serene. Okay, Alvin also. Okay, so because second quadrant is negative for tangent, so we must put minus. Okay. So we must put minus. Okay, so now you see I minimize. So you all can take a shot if you want to. This is actually very basic, but I want to go through this is because I want you all to understand how the quadrant, the negative and positive work. Although it's very basic, but a lot of students always just memorize it, but they don't know what they're doing. Okay. Rationalizing denominator is fixed one. Okay, Alvin. You can in A math you cannot leave denominator got surds one. Yeah, it's a surds law. Correct. You must always make sure the denominator cannot have surds. That's why there's a chapter they teach surds. You understand? So you must always rationalize it. Like you example, when you do your whatever working, then after that let's say you have a 3 over square root 3. Yeah, use other number. Okay, 5. Okay, if you leave your answer in this, you're not saying you're wrong. It's just that they were minus 1 mark because you're not allowed to leave denominator to have surds. So you need to do one additional step, which is to rationalize it. So it becomes 3 square root 5 over 5. Then you will get the so-called full mark. If you put your answer in terms of surds with the denominator, they will deduct 1 mark. Okay? Okay, this question, I'm not going to complete the full question. I just only going to tell you a few things that I want to highlight. First is this tangent B equals to 2. A lot of students thinking, 2 then do what? Okay, because usually you see like you got O over A, got 2 numbers. Then a lot of students, the 2, they don't know do what. So actually it simply is, you just need to put 2 over 1. Yes, put 2 over 1. That is one thing that you need to know. The next thing is, do you see that over here, this pi over 2? It's actually the same thing. It's just that you must understand pi is referring to 180 degree. So 180 divided by 2, this is 90 degree. Okay, 3 pi over 2 is 270 degree. Okay, so I'm not going to complete this question. I'm just going to go through with the quadrant. You see, tangent negative, we know that it is talking about the second and the fourth quadrant. And then after that, tangent B equals to 2 over 1 is positive. So we are talking about the first and third quadrant. Then they tell us that A and B are between 90 and 270. So that means this one is out already, right? Because this is more than 270. Then over here again is 90. So that means this is less than 90. This is out again. So in this question, my angle A falls in the second quadrant and my angle B falls in the third quadrant. You understand? So this is how I do this one. Okay, I love how I do this one. This is a bit different from most of the school. School always asks you all to draw triangle inside, which I don't like to draw inside the quadrant. So of course, the rest I can leave it to you to do it. The answer is here. You can actually try it after the lesson. Question 3 also saying concept. The only difference is it's not number, it's the alphabet. So it's fine because they mentioned that express it in terms of P. So first thing is sine 50 degree, I'll put it as P over 1. This one I can draw out the triangle. And because this is not an alphabet, you can put 50 degree here already. So this is O over H. So that means this is P and this is H. Okay. And then after that, Pythagoras theorem tells me that this is 1 square minus P squared and square root. Okay, so now I have all the third sides in terms of P. So now I'm ready to answer that question. So let's see. 3A. They say sine 230 degree. Okay, 230 degree, you need to know how to put the trigger ratio in terms of the basic angle. So first thing you need to ask yourself is 230 degree goes to which quadrant? You will go to the third quadrant, form this triangle over here. Then the question is, what is the basic angle? Basic angle is over here. So you take 230 minus 180, you get 50. So you know that the basic angle over here is 50 degree. So you know that you put this as, oh, so sine 230 will have the same trigger ratio as sine 50 degree. Then the next question is, do I have to put negative in front? Because sine 230 is in the third quadrant and sine is negative. So I have to put minus here. So minus sine 50 means that, so simply is equals to minus P. Done. So this is for part A. You must know how to present it in basic angle by looking at this diagram. I mean, draw the diagram and see where's the angle fall into which quadrant. And then after that, find the basic angle, put it in terms of the basic angle, and see which quadrant it is at. And then you read that all school teachers are crazy and decide that, I need to put the minus because sine in the third quadrant is negative. Part B. Cosine 50. Cosine 50 easy. I can straight away refer to this triangle. 50 degree is here. So this one is my adjacent. So my cosine 50 degree is simply just square root 1p2 over 1. Okay, this one you don't even have to bother to think whether to put negative or not negative. Because 50 degrees a cube. So definitely it's positive. So I don't have to bother. So this one, you can simplify to put it this way. Done. Now we look at part C. Tangent minus 130 degree. Tangent negative 130 degree. So what do I do with the minus? Do you notice that just now I always have been going this direction, going this direction, going this direction. So when minus 130 simply means that I'm going to go clockwise direction. You understand? I just simply need to do clockwise direction. So over here, so minus 130, you will just go here and then put here. So this is minus 130 degree. And then what's the basic angle over here? So this is 180 minus 130. You know that the basic is 50 degrees. So you know that I can put it as tangent 50. And because it's in the third quadrant tangent is positive. So I don't need to put any minus, okay? So it's equals to tangent 50. And what is tangent 50? You can look at the triangle with the 50 degree. So O over A, so you'll be equals to P over, I shouldn't put the underline there. Okay, so tangent 50 degrees, so it will be equals to P over square root 1 minus P squared. And you are done. That's for part C. Part D, sine 40. Okay, a lot of students jam. They say, my triangle is 50 degrees. Okay, how am I going to find 40 degrees? Okay, take note. There's three formulas that teacher always asks you all to memorize. Actually, I never memorized. Okay, let me think. Okay, so it's like something like sine 90 degree minus theta is equals to cosine theta. Cosine 90 degree minus theta is equals to sine theta. Tangent 90 degree minus theta is equals to 1 over tangent theta. So school teacher asks you to memorize this. Teacher Kangie, I don't like to memorize things. If not necessary for me to memorize, I don't memorize. I don't memorize this. So all I need to do is complementary angle. Complementary angles means two angles add up together is 90. So now look at the same triangle over here. Do you agree that I can actually share the same triangle and say that use another angle is called 40 degrees? So with this, complementary means add up together is 90. So I can use the same triangle. The only difference is my opposite and my adjacent now swap. Because if I'm going to use 40 degrees, now this one will be my opposite. And then this one will be my adjacent. Just now was a different thing, ma. Just now when 50 degrees, this one was my opposite. You understand? Okay, so the only difference is the opposite and adjacent swap. But the hypotenuse will remain as 1. So now, they ask for sine 40. So I can look at the same triangle. Okay, I write part D here. So I said sine 40, it will be O over H. So this time around, this is my O. So it will be equals to square root 1 minus P square over H, which is 1. So it's equals to square root 1 minus P square. So you see, I never memorized any formula. Okay, this is just trying to, if you know this formula is sine become cosine because O and A swap. You understand? Tangent O and A swap. That's why it become reciprocal. You understand? Why this part C no need to rationalize the denominator? No, you cannot rationalize this one because you got alphabet one. Okay. In terms of P, you don't need to rationalize. You're rationalizing when you are like number. You understand? Number. Okay, but that's a good question. A lot of students also ask me. Then they suffer. They say, what? Say this one how to rationalize? Then they rationalize until like tomorrow already. But anyway, just now you all know that you all shouldn't rationalize. Even during exam, you all like wonder how to do it. Even need to rationalize, and then you all find that it's difficult to rationalize. Please just circle the question. Unsure, just move on first. Don't spend too much time on one question, and then after that you have no time to do the behind question. Understand? So we are done with question 3. Actually, this one is not that tough. The only difference is you need to know secant, cosecant, cotangent, what are they? So I always remember by the third letter. Third letter. Okay? See, C. Secant x equals to 2. Third letter is C. It means that okay, secant x is equals to 2. C is equals to cosine. So it will be 1 over cosine x is equals to 2 over 1, right? So that means cosine x is equals to just reciprocal it, so it become half. Okay? Then they say 0 x. Your x range is, answer range is 0 and 180 degrees. Just put it aside, just for your own information. So they ask for sine x. So cosine x is half. Again, I can draw my triangle, right? No, the quadrant first. Cosine positive in the first and the fourth quadrant. But they tell me x is between 0 and 180. So fourth quadrant is out. So that means you only focus in the first quadrant. Same thing, you draw your triangle. Okay. So I'll go very fast this one because it's quite similar. The only thing I need to highlight is about the cosecant and the cotangent. So cosine x is half. 1 over 2. So 1, 2. Then after that, Pythagoras theorem. So 2 square minus 1 square root, it will be 4 square root 3. So this one is square root 3. Okay. So it will means that my sine x will be square root 3 over 2. And because it's the first quadrant, I don't have to bother to put negative because all is positive. Next, cosecant x. This is my part A. My part B. Remember my third letter? Third letter. Look at the third letter is S. So we know that cosecant x is equals to 1 over sine x. And we have already our sine x over here. So it's just reciprocal this. So it's 2 over square root 3. And denominator got such, right? So you need to rationalize it. So multiply by square root 3 over square root 3. So it becomes 2 square root 3 over 3. And this is my answer for part B. Part C, cotangent, third letter P. So that means part C will be cotangent x is equals to 1 over tangent x. And let's find my tangent x. Look at this triangle. So 1 over tangent x is O over A, square root 3 over 1. So it's 1 over square root 3. Again, you need to rationalize. So in the end, it becomes multiplied by square root 3 over square root 3, and it becomes square root 3 over 3. Here, answer is over here. And this is my answer. So this is just simple. As long as you understand the just now the first few questions, this is Easy. The only thing is about the third letter thing. Okay, this is again cosecant all this thing, but the only thing slightly difference is the 90 and 90 minus x, 90 minus x. But just now I remember I talked about the 40 degree and 50 degree. It's the same concept. So let's do cosecant x is equals to 3. Third letter is s. So we know that this is sine x equals to 1 over 3. I just flip shortcut. So sine positive is first and second quadrant. Then they mention x is a cube. A cube means less than 90 degrees. So I'm going to cross this out. I'm going to focus on the first quadrant. So then you can draw the triangle. Okay. Draw out the triangle. This one, since it's in the, okay, I put basic, make it habit. So this will be 1 over 3. That means 1, 3. So I have 3 square minus 1 square root. 9 minus 1. So it's square root 8. Okay. Square root 8 is not the simplest. You need to simplify it. So square root 8 is 4 times 2. So we know it becomes 2 square root 2. So here you put 2 square root 2. So now let's find cosine 90 minus x. You can use the same triangle. Okay, this time around I have to put x already. It's okay for me to put x here because it's a cube. So this is x. So do you agree this is 90 degree minus x? Okay, so it's the same triangle. It's just that my opposite and adjacent swap place. So when they ask for cosine 90 degree minus x, I use the same triangle. This around, I use this as my angle reference. This is my opposite. This is my adjacent. Okay, so they will ask for cosine. So it's a over h. That means it's 1 over 3. And you're done. Part B, tangent 90 minus x. So same thing, I'm going to use the same angle reference. This time around, O over A. So my O is 2 square root 2 and my A is 1. So this one answer is just this. Cotangent x. Change another color. I'm going to do here. So cotangent x, third letter T. So it's 1 over tangent x. Okay. So I can see I use x. So when you use x, you must make sure you use x as a angle reference. This time around, the opposite is 1. So it's 1 over 2 square root 2. Okay, then a lot of students how to simplify this one. This is how I would do. 1 divided by 1, 2 square root 2. Agree? Every time you have fraction over fraction, what I do is I always write it in this form. Then what you do is you just change the divide to multiply and then you flip this one. And then you end up having 2 square root 2. Done. Okay, this is a common thing that students always don't know how to manipulate. You know, like for example, let's say 2 over 3 divided by 5 over 4. Okay, of course, let's say you don't have calculator. Okay, what do? So you always know that you just do 2/3, then you divide by 5 over 4. Then equals to 2/3, then times 4 over 5. We know it when we are doing fraction. Then after that, we use calculator. Then when it comes to algebra, in terms of fraction over fraction, they don't know how to simplify. But it's the same concept. You just put it in this form, put it divide, because over is the same meaning as divide. Then multiply, then just flip the right-hand side. Okay, all these are like basic steps whereby some students may not know, and then after they don't know how to manipulate the algebraic. Okay, so this is for question 5. Okay, question 6, I'm not going to go through. I just want to highlight 2 things. First is 2.5 students don't know what to do. So 2.5, you press the calculator, it will actually give you 5 over 2. See, you have numerator, you have denominator. So it's the same. Okay. Next thing is, do you see this pi over 2 minus x and pi over 2 minus x? Actually, it's exactly the same as question 5. It's just that question 5, write 90 minus x. And pi over 2, remember I said pi is 180 degree. So it's the same meaning as 90 minus x. So it's the same thing. Okay. So that's the only 2 things I have to highlight. The rest you can try it out yourself. Okay, this is the part whereby you are supposed to find x, solve x. It means that you're supposed to find the angle. Okay, so just now previous all the question is it's always finding the trigo ratio value. Okay, not the angle. So over here, very important is you must understand what is your answer range. I call this answer range. Okay, so part A, you write secant x is equals to 2.309, and then third letter is C. So this is cosine x is equals to 1 over 2.309. So of course, this one you can press the calculator for the decimal. 1 divided by 2.309. Okay, so my cosine x is equals to 0.43308. Okay, then next thing is always write out your answer range. Okay, see, I will have two range. Take note. This is something that a lot of school never teach. Then student always confused with the answer. This is my answer range. And they mentioned between. They did not mention 0 and 316 is included. That's why you notice I never put the equal. So it means that if you have an answer 0 and 360, you will have to reject because it's not included in my answer range. Okay, so the answer range is just put there for your reference. So it's just so that when you are doing your working later, you have an answer, you need to check whether is it within the range. And if it's not within the range, you reject it. Next is cosine x is positive. So we know that if we're talking about the first quadrant and the fourth quadrant. So in this situation, because my answer range is all four quadrants, it means that for this case, my x will have two answers. Okay, I will have two answers. So next thing is find my basic angle first. So my basic angle is you always just take cosine inverse, take the positive value. If today in front got minus, I do not put the minus here. But for this question, of course, don't have minus lah. So just cosine inverse 0.43308. Okay, cosine inverse 0.43308, and I will get 64.3368 degree. Okay, so my x. Talking about the first quadrant, my x is just the basic angle. So just put 64.3368 degree. In the fourth quadrant is you take 360 degree minus basic. So over here, I will take, usually I don't write out the whole thing. I just press calculator, 360 minus basic 64.3368. Yeah. So in the end, I get 295.6632. Okay, then you round off to 1 dp, 64.3 degree and 295.7 degree. So I will have two answers. So just some basic, in case some of you, in case some of you, the trigo basic is very bad. If it's those are already very expert, you'll find that I'm talking nonsense. Okay. So student asked me, why got two answers? You see, I work backwards and show it to you. Cosine x is today I key calculator for cosine 64.3 degree. Okay, it will give me 0.43308. Then when I key calculator cosine 295.7 degree, it will also give me 0.43308. You understand? So you are like working backwards. You're trying to find, when I do cosine x is equals to this, what is the possible answer of my x? You understand? First of all, they have to give you a range. If today they never give you a range, actually my answer is infinity. You understand? My answer will be actually infinity. Okay? So in this case, because they give me a range that is only talking about the four quadrant, okay, talking about the four quadrant, then we only have two answers within the four quadrant, which is 64.3 and 295.7 degree. Okay. Okay, so Alvin is asking whether why is it that we cannot put negative over here? Okay. So you see, you're trying to find the basic angle. Okay. Over here in this quadrant, you already decide which quadrant you are involved. I only want to know the basic angle, and then I work out which two angles give me the answer. I don't need the minus. You understand? I only want to know what's the basic angle. But if you put minus, okay, especially if you put cosine inverse negative something, it will give you a big number. Because when you do cosine inverse negative, the first answer they give you is the second quadrant answer, and it's obtuse. Remember, my basic angle is always less than 90 degrees. You understand? So always remember, to find basic angle, you do not need to put negative here. Okay, so this is for part A. So let's move on to part B. Okay, part B over here. Tangent x is equals to minus 1.37. So same thing, what I'm going to do is tangent negative. So I will have second quadrant and fourth quadrant. And because, okay, this one will have two answers. Okay. Then again, basic angle. So I will put tangent inverse 1.37. Don't put the minus. Because if again, same thing, if you're going to put tangent inverse negative 1.37, it give you a big number. Okay, so just key in tangent inverse 1.37 and I get my basic angle 53. Function inverse the positive number will give you basic angle. Okay, so 53.873 degree. Okay, so this is my basic angle. Then after that, to find the two answer is depending on which quadrant we are talking about. In the second quadrant, okay, just now remember our fourth quadrant is take this one, right? So second quadrant is take 180 degree minus basic. Okay, so will be x is equals to 180 minus basic will be 180. I just press calculator, 180 minus this one. So I get 126.126 degree. Fourth quadrant, just now we mentioned 360 minus basic. So just take 360 minus 53.873 and I get 306.127 degree. And degree always round off to 1 dp, 126.1 degree and 306.1 degree. Okay, so that's the two answer. So this is how you do find the angle whereby there will be more than one answer. And it also depending on the range. Okay, so this is for question 7. Maybe the first thing you will ask me, I thought today you said that you're not going to do double angle. Why is it got a double angle here? Okay, this is still not considered double angle. It's just that your theta, which is the 2x, is 2x instead of the normal x. So the first thing is, okay, let's see. Cotangent 2x is equals to 0.699. And this is my answer range. I will put my answer range. And I will have a working range. So what is working range? Working range depends on what is your theta. So for this case, your theta is 2x. So I will find my working range, which is 2x. So times 2 on both sides, I say 0 and 360 degrees. So this is called my answer range. Okay. This question 8, you will not see why I need this answer working range. Okay, later question then I will let you know why is it that answer range is important. So let's proceed. First is t means it's tangent. So tangent 2x is simply just 1 over 0.699. So key calculator 1 divided by 0.699. It will give you, so tangent 2x is equals to 1.4306. Okay, tangent positive is first and third quadrant. Okay, and because we are looking at 2x, so my answer range is 0 to 360 degrees. So I don't reject anything yet. That means I still have to answer first. Then let's proceed to find our basic angle. So tangent inverse 1.4306. So tangent inverse 1.4306. In the end, I will get 55.046 degree. Okay, next is 2x. Always write your 2x first, which is so-called your theta, equals to the first quadrant, which is basic angle. Third quadrant will be 180 degree plus basic. So just take this one plus 180, I'll get 235.046. Okay. And then the next thing is, because my 2x is 0 to 360 degrees, then I always want to check whether I need to go one more round. Okay, sometimes you go backwards one more round, sometimes you go forward one more round. So you do, when my left hand side doesn't have any negative, you do not need to go backwards one more round. This one is 360. Let's check whether we need to go one more round. This one, if I go in plus 360 degrees, it will be out of my range. Agree or not? If it's out of my range, I don't bother to go and plus it. Okay, so I don't need to, and straight away I'll just find my original x, which is 2 of the answer divided by 2. So this one divided by 2 will give me 117.523 degree. So it will be 27.523 degree. Okay, so round off to 1 dp, 27.5 degree and 117.5 degree. So this is the answer for part A. It is part A. I will erase this one and do part B. Okay. Okay, let's take a look at 8B. Cosine 2x equals to blah, blah, blah. So same thing, cosine 2x equals to minus 0.74. This one is already cosine, I don't have to flip anything. Cosine negative is in the second and third quadrant. And same thing, I have to write out my answer range. Look at my theta, which is 2x, so I need to find my working range. Then come back to here, so let's find our basic angle. So cosine inverse 0.74, do not need to put the minus. I need to keep repeating that one because a lot of students always still put the minus. Okay, so my basic angle is 42.268 degrees. So let's find our 2x, second quadrant. So it will be 180 minus this. I get 137.73. The third one will be 180 plus basic. So I get 222.268 degrees. Then again, let's check whether we need to go one more round. So if this one, if I add 360, it definitely be out of my working range. So I don't need to plus, okay? So in the end, I get x to divide by 2 on both sides. So I get 111.134 degrees. I get 68.865, round to 1 dp, 68.9 degree, and 111.1 degree. Okay, this is the two answer. So that's for question 8B. Okay, question 9. Solve the following equation for that range. Okay, 9A. 5 cosine 3x equals to minus 3.45. First thing is divide by 5 first. So cosine 3x is equals to minus 3.45 divided by 5. And I get negative 0.69. So write out my answer range, which is x is between 0 and 360 degrees. My working range is 3x. So when I times 3, this one, of course, is just 0. But my 360 times 3 is 1080 degrees. I see the range is bigger, right? So later you will have to go so many rounds. You see, that's why so many answers here. So basic angle. So cosine inverse 0.69. And I get 46.369. Then after that, I will write 3x. Always write out your 3x equals. Just now I forgot. Oh, I forgot my quadrant. Okay, to here, no space. So my cosine negative is in the second and third quadrant. Okay, so it's so important because I need to know which quadrant it is at. Then we know that over here I need to do which one. So second quadrant is 180 minus the basic. So 180 minus 46.369, I will get 133.631. The second one is 180 plus basic. And I get 226.369. You will always have the first two answers to work with first. Then after that, you have to see whether you need to go one more round. Again, my left-hand side don't have any negative involved, so I don't need to minus 360. So I need to check plus 360. This first one, when I plus 360, is definitely within my working range. So I need to include it in. 133.631 plus 360 will give me 493.631 degree. This one, when I plus, still can go one more, still will be within my answer working range. 226.369 plus 360, I will get 586.369 degree. Then this one, I need to plus another round. Why? Because it's still within my working range. So 493.631 plus 360, it will be 853.631 degree. This one plus, still within, I need to plus. So 586.369 plus 360, I will have 946.369 degree. So then I say, hey, do I still need to plus some more? You see, this one, if I go and plus 360, it will be out of my 1080 already. So I know that I don't have to plus anymore. And I know that I will have 6 answers because all these 6 answers are within my working range. That's why my working range is important. My working range will determine I need to work until where. Okay, those which is not within my working range, I can just ignore them. Understand? So I have 6 answers for this case. Then solve x, which is I have to divide by 3 for all of them. So it will be 133.631 divided by 3. Okay, blah blah blah. This one, of course, I don't need to do lah. So answer is, you see, this one divided by 3, divided by 3, divided by 3, da, 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 da. So you have 2, 4, 6. You have 6 answers. So this one, I will leave it to you to go and divide by 3 lah. I'm going to not press it 6 times. Okay, I'm not going to do that lah. So a lot of students ask me, why need to go so many rounds? Okay, now let's do the backwards. Remember just now we do cosine 3x is negative 0.69. What you're trying to do, you're trying to find out what x value will make this equation true. So let's take, for example, one of my, let's say this answer, 195. This is my x mark, correct? So I will check cosine 3x, 3 times this 195.5 degree. You can press the calculator and see whether does it give you negative 0.69. Okay, so cosine 3 times 195.5. So it gives me negative 0.688. Okay, of course, this one round off still can get negative 0.69. Right? Just around there. So you see, if I'm going to key this one, same thing. If I'm going to key cosine 315.5 degree. Okay, so cosine 3 times 315.5 degree. Again, it will give you negative 0.688. So you see, what I'm trying to find is, I'm trying to find all the possible x value that will give me, that will make this equation true. I will have a lot of answer when they did not give me a range. You understand? Okay, so that's for question 9A. Question C will let you understand why I need my working range. Okay, so tangent 2x minus 78 degree. This time around, the theta is a bit complex. It suddenly have a minus 78 degree there. Okay, equals to negative 1.57. Okay. Although I encourage students to ask questions lah, but Alvin, you don't purposely ask stupid question. Okay, anyway, just to let you all know, Alvin is a private tutor. He's not a student. Okay, so I asked him to join in to actually understand, see how I teach, and so that he can actually bring forward and help more students. Okay. Okay, so over here, tangent blah 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 equals to minus 1.57. So same thing, tangent negative, let's go through. So it will be in the second and the fourth quadrant. Okay, let's start. Our answer range will be x is between 0 degree and 360 degree. And then after that, see, this is a bit different. This time around is 2x minus 78. So let's do my 2x first. So times 2, I will get 0. And then after that, 720 degrees. Then I will have 2x minus 78. So 0 minus 78, so it's negative 78 degree. And this one, I need calculator. So 720 minus 78, it will be 642 degree. So you see your working range got negative 78. Okay, just now the previous question, you can see that my working range is always start from 0. And that's why you see that I never go minus 360 degree. Okay, but when your left hand side, right, working range has minus 780, you might need to minus 360. So later we will see whether we need to. Now let's find our basic angle. So it will be tangent inverse 1.57. So it will be tangent inverse 1.57 is equals to 57.505 degrees. Okay, so let's find our theta, write out the whole thing. First, no, they're asking for second. So straight away take 180 minus this. So you will get 122.495 degree. Fourth quadrant will be 360 minus 57.505. You get 302.495 degree. Okay. Of course lah, if you ask question which is not related to the question, I already kick you out, okay? Okay, now question 9. Okay, so this one, see, this is the first two answer, correct? Then after that, I need to see whether I need to go plus 360 and minus 360, okay? So after that, let's see. This one, I'm going to plus 360. Oh no, let's try minus 360. If I do minus 360 degree, I will go to negative, so I don't bother. This one, if I minus 360, I may fall into the range. So I will take 302.495 minus 360. You will give me minus 57.505 degree. So you see, it's within my working range. So I'm going to keep this there, okay? So now let's go to plus 360. This one plus 360 is within range. 122.495 plus 360. You will give me 482.495 degree. This one minus 360 degree, I can tell you, 9 out of 10 students, or maybe even 10 out of 10 students don't know. Really, the minus 360 degree, a lot of students don't know. Okay, because a lot of time they always do 2x, 3x, they only like go one round. But when they have involved the minus, they don't know about this one. Okay, so let's continue. So just now I plus 360. So this one, let's check whether this one, if I plus 360, will it be out of this range or not? So 302.495 plus 360, it will be 662. Out of my range already, right? So I don't bother to write it out. So that means I know that I will only have 4 answers. But this is not my final answer yet. So take note that this one 2x. The next step you need to do is you need to plus 78 first. The common mistake the student do is they go and divide by 2. Then do the 78. Sorry, it's not minus 78, it's plus 78. As in, they do it and divide by 2 first. But no, you have to plus the 78 first, then divide by 2. So now 2x, all 4 of them, you go and plus 78. So 122.495 plus 78. Give you 200.495. 302.495 plus 78. 380.495. Negative 57.505 plus 78. You see, now it becomes positive already, ma. You see? That's why the working range is very important, okay? 482.495 plus 78. Then the last step is, because you're supposed to solve x, not solve 2x, so just do one last step, everything divide by 2. So divide by 2, 280.2475. Yeah. Okay, 20.495 divided by 2. I have 10.2475. 380.495 divided by 2. I will have 190.2475. Okay, so 200.495 divided by 2, it will be 100.2475 degree. So round off to 1 dp, 100.2 degree, 190.2 degree, 10.2 degree, and 280.2 degree. Take note, always write your answer in the ascending answer. Okay, see here one small one. So you will say therefore x is equals to 10.2 degree, 100.2 degree, 190.2 degree, and 280.2 degree. You see that all 4 answers are within my answer range. Okay, so when you do your working range, you will not waste time doing a lot of extra numbers, and you will also not miss out any number. You understand? For this case, the tricky part is because of the negative. Okay. Okay, question 10. 10a. Sine square x minus sine x cosine x equals to 0. Okay, write out my answer range. Okay, this one is something like a trigo quadratic equation. Okay, you just visualize this way. If today I have, let's say, x squared minus 3x equals to 0. Algebra, right? Quadratic equation, right? How do you solve this? You take out common factor x minus 3 equals to 0. You solve x equals to 0 or x equals to 3. Two answer, right? So actually same apply for the trigo. Okay, so this case, I have my common factor sine x. So I will say sine x, take out common factor, I will left with sine x minus cosine x equals to 0. Then I will say, oh, so sine x equals to 0 or sine x minus cosine x equals to 0. Okay, so sine x equals to 0, take note, sine x equals to 0, when you go and do sine inverse 0, the calculator will only give you one answer, which is 0. But you must understand that sine x equals to 0, there are actually three answers. So every time when you're solving sine, cosine for extreme value for 0, 1, or -1, I will want you to remember by the trigo graph. So you see, if I'm going to plot my sine graph, it will be like that. So sine x 0, where is 0? 0 is here, here, and here. So we actually have three answers because this is 0 degree, this is 180 degree, and this is 360 degree. So when I solve sine x equals to 0, I should have x equals to 0, 180, and 360 degree. And do I need to reject the 0 and 360? It depends on whether your 0 and 360 is involved or not. For this case, it is involved. So I do not reject and I have three answers for this case. Then after that, let's take a look at this one. Some students jam, got sine and cosine, how to solve? When you have sine and cosine, just need to check on two things. Check on one thing. The right hand side, is it a 0? It is a 0 means that you can change this to tangent. You understand? Okay, if my right hand side is a number and it's not a 0, then you will have to use R formula. Okay, but I'm not going to touch on R formula today. So for this case, because my right hand side is 0, that means I can change it to tangent. So sine x equals to cosine x. How do I change it to tangent? I divide by cosine x. So sine x over cosine x. So cosine x divided by cosine x is equals to 1. So in the end, this becomes tangent x equals to 1. Okay? And tangent x equals to 1. Okay, I can take this as only for tangent, you can do the basic angle. Okay? So for tangent x equals to 1, you will say, oh, so first and third quadrant. Why right hand side not equals to 0 must use R formula? Because if you don't use R formula, you have both sine and cosine, you cannot solve it. Okay, you need to use R formula to change it to either purely sine or purely cosine. Okay. So first and third quadrant. First and third quadrant, and my basic angle for tangent x equals to 1, it's 45 degree. So my x will have first quadrant, which is 45 degree, 180 plus this one, so it's 225 degree. So in the end, for this question, I have 5 answers. I will say x is equals to 0, 45, 180, 225, and 360 degree. So this question, I have 5 answers. Okay. So this question I want to highlight is sine x equals to 0. Please remember by the graph, you have 3 answers. If you press calculator sine inverse x, sine inverse 0, it will only give you one value, which is 0. Okay. And then when this one, don't need to panic. Then for this case, you can change it to tangent and then just solve it like a tangent. Okay. Let's go to 10B. Now it's only 10A. Okay, question 10B. So tangent square x equals to 9 over 4 tangent x. So same thing, this one is a quadratic equation. Okay, take note, you cannot divide by tangent x. It's the same concept as when you're solving quadratic equation. Like for example, if I have x squared equals to, let's say 9x. I don't have fraction. So if I want to solve this, x squared minus 9x equals to 0, I have to factorize the x, right? A lot of students say, hey, I can divide by x throughout. Then I become x minus 9 equals to 0. You can only divide by a constant, but you cannot divide by x. Because when you divide by x, you will lose x value. Because when you divide by x, you actually lose the x equals to 0. then you lose 1 mark also. You understand? So cannot divide by x. So same apply for this one. You cannot divide by tangent x. Okay. So let's proceed. So take out. So I'm going to bring it over first. So take out common factor tangent x. I have tangent x minus 9 over 4 equals to 0. So I have tangent x equals to 0 or tangent x equals to 9 over 4. So tangent x 9 over 4, what you do is first quadrant and third quadrant. Okay, so everything else is the same. This one I'm not going to do it. Take note, tangent x equals to 0. You can actually memorize it by saying that, oh, it's actually the same thing as sine x equals to 0. So this one I have 3 answers, 0, 180, and 360 degrees. Okay, so that's why you see that I have 0, I have 180, I have 360 degrees, and this one, of course, will give me 2 answers, which is this and this. I'm not going to work it out. This one, leave it to you. 11a. So 3, so it's tangent square x equals to 1 over 3. Agree? So I want to solve tangent x, I will do square root 1 over 3. Take note, when you square root, you always have plus minus, right? So in this case, you have plus minus. And when you have plus minus, it means what? It means that for this question, all 4 quadrants also have answer. So automatically, you have 4 answers. And you see the difference? Do you see that my answer range this time around is radian? It's no longer 360, right? So then in this case, you must know that you have to work them in terms of radians. Okay, so let's find our basic angle first. So my basic angle will be equals to tangent inverse square root 1 over 3. Take note, you have to be in radian mode. You know, for this case, cannot be in radian mode. You know why? This one, let me simplify first. This is plus minus 1 over square root 3. You must know how to recognize that 1 over square root 3 is actually the nine trigo ratio that is supposed to memorize, which is links to the special angle. Okay, so when I use degree, the cheat way to do is that is you do tangent inverse 1 over square root 3. And it will give me, oh, I forgot tangent inverse 1 over square root 3. It will give me 30 degrees. So I know that, so my basic angle is in terms of pi, will be pi over 6. Okay, you cannot put in decimal. Whenever your basic angle, this is common mistake I shouldn't do. Whenever your basic angle is special angle, 30, 45, or 60 degrees, you cannot leave your answer in the decimal radian. You must leave your basic angle in terms of pi. 30 is pi over 6. 45 is pi over 4. 60 is pi over 3. Okay, so in this case, because my basic angle is 30 degrees, so I have to put it as pi over 6. So let's move on. So my x will be all 4 quadrants. So my first quadrant is pi over 6. My second quadrant is pi minus pi over 6. And then my third quadrant is pi plus pi over 6. My fourth quadrant is 2 pi minus pi over 6. Then student always ask, hey, how to simplify this one? So it's just like normal fraction. You see, this is over 1, right? I times 6 times 6, 6 pi minus pi, I can write it as 5 pi over 6. Okay, this one, 7 pi over 6. Okay, times 6 times 6, 12 minus 1, so it's 11 pi over 6. So that's why I have this 4 answer in terms of radian. Okay, so that's for question 11a. So take note, for this case is all 4 quadrants are involved, and also that you have to put our answer in terms of pi. So if you give your answer in decimal, they will deduct wrong. They will mark wrong. So please remember that. Okay, I'm going to do just, let's see. I'm not going to solve the full equation. I'm just going to start on the first few parts. Then you all will know how to solve the behind. Okay, let's say for example, okay, I'll start from ABC. This one is the one that I say that I can change to tangent. Cosine x is equals to 3 sine x. So actually I can divide by cosine x, it will become 3 tangent x equals to 1. So in the end, it becomes tangent x is equals to 1/3. Right? So again, First and third, the same. This one. The only thing I can do is I can change the secant x, third letter, to 1 over cosine x. Then I cross multiply. I will have 3 cosine square x equals to 1. Cosine square x equals to 1 over 3. And cosine x is equals to square root 1 over 3 and plus minus. So take note, this one is all 4 quadrant. The rest, I leave it to you. And now part 12c. Sine x equals to tangent x. So I'm going to split this to become sine x over cosine x. Okay? Then what can I do? Just cross multiply. So I get sine x cosine x equals to sine x. How to solve? Bring it over, take out common factor sine x. Take out sine x. I will have cosine x minus 1 equals to 0. So I have sine x equals to 0 or cosine x equals to 1, and then you can solve. Okay, so that's for part C. Okay, now let's take a look at part D. We can put it here. Ta-da! So 4 cosine x is equals to 2 cotangent x. So 4 cosine x, I can't do anything to it, but I can change this one to 2 cosine x over sine x. These two put it at the top, put this one over 1, cross multiply. So 4 sine x cosine x is equals to 2 cosine x. Everything throw to the left hand side. So 4 sine x cosine x minus 2 cosine x equals to 0. Take out common factor cosine x. 4 sine x minus 2 equals to 0. Again, I have two answers. Cosine x equals to 0 or sine x is equals to 2 over 4, which is half. Then you the rest you can do. I only helping you on the first part. The rest is always similar. 2 cosine x minus sine x equals to 3 over 2 cosine x plus sine x. Every time when you see and it's so complex, what you need to do? You need to combine to single fraction on both sides, which is like that. It's already considered single fraction on both sides. Then what do? You cross multiply. So I'm going to cross multiply. I will get 2 cosine x minus sine x rainbow with 2 cosine x plus sine x equals to 3 times 1, which is 3. Then you will have to do your rainbow. This one times this one will give me 4 cosine square x. This one times this one will plus 2 sine x cosine x. This one times this one is minus 2 sine x cosine x. This one times this one is minus sine square x equals to 3. Then after that, this one actually is like terms, right? Then plus and plus 2 minus 2 means they already net off. This one cancel off with it. So I left with 4 cosine square x minus sine square x equals to 3. Then what do I do? Over here, I will have to use the identity. Okay? Yes, we will use the identity. Okay? The identity will be using the, okay. Okay, so you will be using the identity. We know the formula sheet that there's a few identity that you need to use. So sine square x plus cosine square x is equals to 1. Okay, this identity it can help you to change sine square x to become cosine square x or cosine square x to become sine square x. So this one you want to choose either one also can. So let's say I make sine square x a subject. It'll be 1 minus cosine square x. So it means that I'm going to change sine square x to become this. So it'll be 4 cosine square x minus bracket 1 minus cosine square x equals to 3. So 4 cosine square x minus 1 minus plus cosine square x equals to 3. 4 plus 1, so it's 5 cosine square x equals to 3 plus 1, so it's 4. So in the end, I get cosine square x equals to 4 over 5. Cosine x is equals to square root 4 over 5 plus minus. All 4 quadrant is involved, and then after that, the rest, I can give it to you. Okay? So this is for question 13A. So question D, cosine square, you see, need to know that 1 over cosine square x. See, right? So this is actually equals to secant square x. Okay? And this one, over tangent 1 over cotangent x is actually equals to tangent x. You see, this is 1 over tangent x, agree? And when you flip, it actually just is tangent x. It's just confusing you. So in other words, this become 3 secant square x equals to 7 plus 4 tangent x. Then look at the identity. Do you see that because I can change my secant square to become tangent square. So it will be 3 open bracket 1 plus tangent square x equals to 7 plus 4 tangent x. Open up, 3 plus 3 tangent square x equals to 7 plus 4 tangent x. So this is a quadratic equation solving tangent x. So since it's a quadratic equation, I'm going to throw everything to the left-hand side. So 3 tangent square x minus 4 tangent x plus 3 minus 7 equals to 0. 3 tangent square x minus 4 tangent x minus 4 equals to 0. So this is quadratic equation. So 3, negative 4, and minus 4. It will give me tangent x minus 2. And 3 tangent x plus 2 equals to 0. Okay. And then after that, this is, you solve it. So it becomes tangent x equals to 2 or tangent x equals to minus 2 over 3. So of course, the rest I leave it to you to do. Okay. So that's for question 13D. Okay. So you need to know this. Maybe some of you don't know how to change this one. Okay. And then this one, they're just trying to confuse you. Simply, it's just tangent x. And we can always use the identity to change them. So how do I know change which one, right? Because tangent x, I cannot change, is no, don't have square, So we will always work on the one whereby there's square. And then we look at the identity and see whether we can change it like the friend. Then I can see that, oh, I have one identity whereby I can change the secant square to become tangent square, which is related to the friend at the side, So I know that I will have to change them to be a quadratic equation solving tangent x. Okay, sine x, blah, 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 blah. Okay, B, Okay, B. Sine x plus cosine x, cotangent x equals to 2. And take note, this one in terms of radian. Okay, so I can't change this, The only thing I can change is this one. So sometimes you may not know what to do yet. Okay, so you just change along the way and then you will slowly see some hint. So cotangent x, the same meaning as cosine x over sine x equals to 2. So sine x plus, this one I'm going to put like that, break up. So it's cosine square x over sine x equals to 2. Then what do? Combine into a single fraction. So this is over 1. So times sine x, so it becomes sine square x plus cosine square x over sine x equals to 2. And identity, that means that this one is equals to 1. So it becomes 1 over sine x equals to 2. Cross multiply, 2 sine x equals to 1. Sine x equals to half. Ta-da! So, the rest I leave it to you. You see, one equation looks like so complex, but you can just slowly change. Sometimes you may not know at the start. Just do it, try it first, okay? And you see, while I do change, it becomes so simplified. Then I know how to do it already. Okay, just take note that this one is in radian. Make sure that you're in radian mode. And this is also another one which is the what's that called? The special angle. That's why your answer you have to leave in terms of pi. You see? Part C, 4 plus sine x tangent x. Yeah, sorry, I write in the back ugly. 4 plus sine x tangent x equals to 4 cosine x. Same thing, I can't change my sine, I can't change my cosine, so I'm going to change this one. So put as 4 plus sine x over cosine x equals to 4 cosine x. Right, same thing, this one, bring it up, so become 4 plus sine square x over cosine x equals to 4 cosine x. Same thing, we're going to combine into a single fraction. 4 over 1. So this one will be 4 cosine x plus sine square x over cosine x equals to 4 cosine x over 1. So both sides single fraction, cross multiply. So it becomes 4 cosine x plus I thought it's a 5. Sine square x equals to 4 cosine square x. So you see that so student ask, yeah, I change to sine square x or change to cosine square x. You see, this one cosine x, I cannot do anything, correct? So in other words, my cosine x will stay there. I can't do anything. So in this case, I will have to change my sine square x to become cosine square x. So 4 cosine x plus, open bracket, 1 minus cosine square x equals to 4 cosine square x. So it becomes 4 cosine x plus 1 minus cosine square x equals to 4 cosine square x. I'm going to throw everything to the left-hand side. I want to keep this as positive. So 4 cosine square x plus cosine square x minus 1 minus 4 cosine x equals to 0. 5 cosine square x minus 4 cosine x minus 1 equals to 0. So it's a quadratic equation. 5, negative 4, and negative 1. So I have cosine, I have cosine x minus 1. I have 5 cosine x plus 1 equals to 0. So cosine x equals to 1 or cosine x equals to minus 1 over 5. And we are done. This is for question C. 14C.